Hi, I'm going to walk you through the steps that we covered in the lab the other day for setting up a model to mask your raw data and then project it to a useful projection. So I'm just going to kind of summarize the steps we did here, probably in two parts. The first part will just be the setup and the different file structures and running the model, saving the project, and then I'll do a second video where I just kind of repeat the process, and we can kind of go from there. So I'm going to start by showing you the file structure, what we kind of decided on in the lab yesterday. So I've got our catalog open, and I recreated what I saw the students working on. So I try to just kind of recreate that, and then I'll talk through a little bit about why we decided to do what we did, and hopefully this will be a useful resource for you. So I've got a folder here called SnodasData. You can see I've got a couple of years in here, a couple of seasons worth of data that I'm going to download and work with. And so I have this kind of all set up, and then I'm going to go through the process here to kind of recreate what you see up here. That's what the video will be about. So to get started, here's the file structure. I tried to replicate what I saw on the machines, the student machines. So 04, 05, and then we've got a lake, and then a lake-to-lake event. And then my acronyms probably aren't correct, but here's a single lake parallel event. I'm not sure if that's actually one, so I apologize for that. And then broken down into the months of that season. And again, you see how it's nested. I'm going from a lake-to-lake event to a more specific event to a specific time period, and then down to month. What I think we decided on yesterday was to kind of build your database information, your masked and your projected data, build a geodatabase here at this level, at the sub-event level or the event level. So I'm going to build a geodatabase here at the single lake parallel event level. Hopefully this is making sense. The thought was that we would actually have, you would then be able to go back to that specific sub-event and grab the data that you needed. And again, this would be mirrored up here in a lake event. This just happens to be lake to lake. And you also notice here that I've got, just to kind of build it out, so you can see here's the second year of information that I would kind of replicate building a geodatabase in. What I thought as I got thinking more about this is that you probably want to build a project and your toolbox, and then just the masked geodatabase information. I'll preview it here. This is the mask that I built for myself, just kind of like Lake Ontario, Lake Erie kind of area. Put those at the root, because you'll be reusing this project over and over and over. The only thing you'll be changing is the geodatabase where you'll be saving it. So with this project built and the toolbox I'll include, you'll be able to point the tool, point the model, which I'll show you here, that we created yesterday in the lab. You'll be able to point that model at this geodatabase, and that's the only thing you'll need to change the first time you start processing something for a specific event, is just changing the geodatabase where it's going to get stored. So hopefully that kind of cuts out a little bit of hunting and pecking and clicking into the different geodatabases. So I'm just going to go ahead and get started with what I need to do, and again, I'm going to try to do this in a couple different parts just so the videos aren't so long. So as I said, I have this one already set up, and here's one that's got basically contains the same information almost exclusively. And so you can see I've already kind of processed some data for a couple of events, or processed 3 days of data for one specific event that's single lake parallel, lake to lake. Again, I apologize if my acronyms are not quite right. And then my mask. So those are the pieces I'm starting with, and I'm going to kind of create what you see up here in this first folder. So I went ahead and I'm going to go in and create I created a geodatabase at the sub-event level, which is a single lake parallel. And you can see I've got a geodatabase, an empty geodatabase waiting to be kind of populated with some information from the October to December time frame. You see the raw data here, so I'm going to process this raw data and dump it here in this mass data geodatabase, again at the sub-event level. I think Jessica thought that was the best spot, and I kind of agree. It's a great place to kind of aggregate your data. So you can find it again. Out here I have a mask geodatabase. Again, this is at the root. And so what I'm going to do is build a project and a toolbox around this geodatabase at the SnodasData kind of root folder, just so I know where to find it, and I'll keep coming back to it to process all the information in all these subsequent folders. Okay, so that's a little bit about the file structure. Hopefully that makes a little bit of sense. So the first thing I want to do is put our catalog against the side of the window. Again, I like to work with both windows open. You can do any way you like. I tend to like this because we can click and drag, and I'm going to launch ArcMap up here. I'm going to start a new project, and what I'm going to do is add to this project the Lake County mask and the first set of raw data, and I'm going to build my model and then save my model right here in the same kind of root level where the mask is. And then we'll save the project as well. So what you'll be able to do is reopen the project and add the toolbox, the custom toolbox you're going to create, the custom tool you're going to create for yourself, and reuse that at any point in your data. So I've launched ArcMap, and I'm going to drag in my mask. So I've got my mask set up, and at this point I'll just go ahead and save this project. File, save as, and I'm going to put it in my SnodasData data, because again I'm just kind of walking through this whole process just so you get a sense of how this works. And I'm going to save it right here at the root, because I'm going to come back to it. So no matter what season I'm working with, 04, 05, 06, 07, 08, 09, whatever iteration there is, I'll be able to come back to this project and apply the tool and the project to that information. So I'm going to save this as mask project data. Could be anything really. So I'll save that. I'll come over here and I'll refresh my folder. Let me refresh this. You can see now I've got this project here. Alright, so now I've got the project saved. It's got my Lake Country mask, Lake County mask, and this is, I'm going to extract my raw data and then project it all in one step using the model builder. So my first data set is a lake-to-lake event, single lake parallel, and what I'm going to do is go into November 04. I just grabbed this data at random. Here's my raw data. You can preview it. What I'm going to do is extract it, project it, and it will show up here in this mass data geodatabase again at the sub event level. So I'm going to drag that in. This is a good sign. That means it has an unknown spatial reference. That's great for us. That means we can work with it to define it. So it's all set up. I'm going to resize some things here so you can see. Okay, so I could check these on and off, etc. So the first thing I want to do is open the model builder. It's this flow chart looking button here, and what I want to do is add a tool to it. So I can float this over here, and I'll come over to the search window, type in tools, and the first thing I want to do is extract by mask. So I'm going to type the word extract, and I find it here about a third of the way down, or the fourth item down, extract by mask. So I don't want to open the tool. What I'm going to do is click on it, click and hold, and drag that tool right here into this interface. So now you can see I've got a tool set up with an output raster. Okay, So now what I'm going to do is I'm going to double click on the hammer and set it up. My input raster, which was over here in the table of contents, is this first raw data set from November 2004 from my sub event. Add that in. My input mask, feature mask, is this polygon file here, which is, I call it Lake County mask. Again, it comes from this mask geodatabase. Now now I have to tell it where do I want it to go. I have that. Move this out of the way. Well, I can't. You see the mask geodatabase. That's where mask data. That's where it's going to go. Again, this geodatabase sits at the sub event level. Let me make sure I'm in the right. So 0405. So I'm in my SnodasData 2. Again, I'm just kind of recreating for you what I did over there. Lake to lake. And you can see that's where it is. Double click inside, and I'm going to call this lake to lake, November 2004. Let me do this. 11 November 2004. And click save. You could be a little bit more descriptive. I kind of leave that up to you because you have a file folder structure that's set up, so the folder kind of tells you what the data is, but I could add single lake parallel or whatever other acronyms I want to that. And click OK, and it should start filling out our model. So you can see here, I'm going to move this over, resize it a bit. You can see I've got the raw data here, the mask. They're both being added to this tool, and here's our output. When you're working with models in Model Builder and ArcGIS, this is considered, this green oval here is an output of these two and this model and this tool. This is what we consider a intermediary file. It will populate this geodatabase. It could be added back when you need, if you need to. I think Jessica said she's going to delete hers, and that's fine. You can probably get rid of it because you can generate it again very quickly if you really need to. So that's the first step. Second step is to kind of repeat the process of searching and adding a tool to this interface. And so what we'll do is we'll extract it, and then the next step is to project it to a useful projection. So again, I'm going to open the search interface of this little blue dot, strip out the extract by mask, type the word project, or in this case project, and since it's a raster, we want to project a raster. So we're projecting raster data. I'm going to grab that. A little bit more tools are returned. Second one down, again, click on it, hold, drag that right in the interface, and that'll set up that tool for the second step in the process. One note is if you can click on these individual objects and highlight them, and you can move them around. You can also shift click, select both of them, and then kind of move them as needed to kind of rearrange the space to kind of keep it looking neat. I've made really complicated models in the past, and you can have a lot of inputs and outputs, so it's good to kind of reset everything. You can always hit this button too, which will auto layout. Sometimes that is not as useful to do, so in this case I'm just going to shift click and grab them both and kind of align them to the end here. So what I'm going to do now is set up the project raster using this intermediary file here. And they're both, again, are going to wind up being stored in this mask, or in our sub-event geodatabase, masked data. All right, double click the tool, input raster. I'm going to use this lake to lake 11 November 2004 intermediary file. It's this file here. Doesn't exist yet. That's why I've got the little recycling thing. Okay, you can see it's got an input coordinate system. Output raster. This will actually work, except it's going to the wrong place, and it's too long of a name. So I'm going to do this. Go into mass data, make sure I'm in the right spot. I'm going to call it lake to lake 11 November 2004 PRJ. Add PRJ for projection. Click save. output coordinate system. I'm going to choose that from the list. It's going to be projected. Scroll down, and we're going to use, continental level, because we're covering a large region. North America, and I believe we're going to look at USA continuous equidistant conic. That was one we worked with yesterday, but you can choose anything from this list. Same process. Click OK, fills that out, apply, and OK. You can see it completes our model. So this model is actually set up to run now. What I can do is click the model and validate the entire model just to make sure there's nothing out of place. This is a pretty simple model, pretty straightforward. There shouldn't be any issues, so you shouldn't get anything when you validate. Click model, run entire model, and it'll step through the pieces that it's working on as it does it. Let me move this out of the way. And when the model is completed, you'll see that these drop down. There's now a drop shadow underneath the tools and the outputs. That's to indicate to you that this model has been run. So now, if I move this model aside, come back over here to my Arc catalog window, I can right click on this mass data geodatabase, refresh it, and you'll see that I've got the mask data unprojected and then my projected version of it. Okay, so that's the two-step process for doing that. So what you want to do now is you've saved the project, now we want to save the model so that we can reuse it again. So what you want to do is come up to Model and Save As. And again, I'm going to try to put this right at the SnodasData level so that it will live there and I can use it again. And it'll be right near the MXD file. So to save a model, you have to create a toolbox. So you want to create a new toolbox to store your custom-made model in. So I'm going to click this new toolbox, little star on top of the red toolbox. My new toolbox I'll call Extract, Project, Snodas. Anything can be named anything you want. I'm going to go into the toolbox and name the model Extract and PRJ. Again, any name that suits you will work. Just want to avoid parentheses and stars and exclamation points. Any kind of weird character, don't recommend that. And again, no spaces ever, underscores. Click Save. You can see now it's assigned to that. Before I close out of this project now, I'm going to remove some things because I want to reuse this project and this model on multiple data sets and not just this original raw data set. So before I shut down, what I'm going to do is I'm going to come over here. Since I don't need it anymore, I've already processed this data from 11 November 2004 for this specific event. I can right click, remove, and then I can come into the model, select it here, right click and delete, and see it kind of resets the whole model and says, okay, we're missing an input, and that's good. I can now click the save disk, exit the tool, click the save disk here, and exit the project. And that is kind of the setup of a toolbox and adding your raw data, extracting and projecting all in one step. So if we kind of refocus on our catalog, I will look at my SnodasData, refresh this entire folder, and you'll see now I have created exactly the same thing here. I've got a mask geodatabase. Here's the mask I'm using. Here's my toolbox with the tool I created and the project file that I'm going to use to kind of keep doing this. And then again, at my 2004-2005 season, lake to lake, single lake parallel, made that up myself. You can see in my masked data geodatabase at this sub-event level, I've got my unprojected data, my projected data. Again, you can always delete this by right-clicking on this and delete it if you don't want it anymore, and do a little cleanup there. You don't have to. if you're running low on storage, it might be advisable. And that is the first video I'm going to put together related to setting up your project, your file structure, and creating a model and saving the model with the project so that you can reuse it again. In the next video, it'll be a little bit shorter. All I'm going to do is run through the process again and show you how to go from something you saved to calling that model back in and then running it against 2 more data sets.